Hello, my name is Josie, and this is Physics 2 test number 1. And I'm going to do problem number 3, which says, the leg in the image below is in a cast. The cast and leg together have a mass of 18 kilograms, and the center of gravity is 35 centimeters from the hip joint. The supporting sling is under the leg at 85 centimeters away from the hip joint. What is the tension in the sling, assuming the leg is at rest and is horizontal? So first I'm going to write down everything I know. The leg in the image below is in a cast. The cast and leg together have a mass of 18 kilograms. Mass equals 18 kilograms. And the center of gravity is 35 centimeters from the hip joint. So D equals 35 centimeters. The center of gravity is 35 centimeters from the hip joint. The supporting sling is under the leg at 85 centimeters away from the hip joint. Okay, so I'm going to do 35 centimeters DC for center of gravity, or actually DG for center of gravity. And then I'm going to do D supporting sling, DS, equals 85 centimeters. Okay, for the hip joint, what is the tension in the sling, assuming the leg is at rest and is horizontal? So T equals question mark. Okay, I'm gonna just draw this boot on my paper so I can see it on my paper. So we have that, we have T up, and then we have MG down, and we have 85 going from the supporting sling 85 centimeters away from the hip joint. Oh yeah, so 85 from the hip. Actually, I'm gonna just turn all my centimeters into meters so I don't have to do it later. So 0.35 meters and 0.85 meters. This is 0.85 meters, and then 18 kilograms and 35 centimeters from the hip joint, also from the hip joint. 0.35 meters. Okay. So now I have what I know in my picture. So since it's hip joint, I'm thinking torque, but what is the tension in the sling, assuming the leg is at rest? Or equilibrium, because at rest, okay, since it's at rest, T equals mg. So T, where mg is gravity times the weight. So gravity equals 9.8 meters per second squared times 18 kilograms. So that would be T, but we have our distances. But we know torque, because it's hip joint, equals force times distance. So tension up is the force up. Mg is the force down, which we know mg is weight times gravity. So we have force, so then we multiply it by distance. So T times 0.85, because that's the one farther from the hip joint, meters, equals, I'm going to just do the 9.8 times 18. 9.8 times 18 equals 176.4 newtons, because that's a force. and then times 0.35 meters. And then that should get us T. 176.4 times 0.35 equals 61.74 equals 0.85 meters times T divided by 0.85. T equals 72.635, and we have two sig figs in our problem. T equals 73 newtons is the tension in the sling. Here's my work. And does this make sense? Well, if his weight is 176.4 newtons, then we would assume the tension in the sling is going to be less than his weight because the leg acts as like a lever. Wait, does it? This makes sense because it's not going to be as much because weight is distributed. And if we were like, when we were like learning about the torque, when you're farther away, you use less force because the force is distributed through a longer thing. So 176. So yes, it makes sense because the answer should come out as less than his weight because it's distributed over a larger area. So my final answer, 73 newtons of tension in the sling, and it makes sense. Okay, thanks.